CNBNENRF? That makes no sense to me. Let's do an MD5 hash. Come on, there's no way. That's just complete gibberish. It's instant! What we are doing today is we are going to be cracking passwords using Python, and how we're going to do that is through cryptography. So there are very well-known cryptographic functions out there. The two that we're going to be dealing with today are SHA-1 and MD5. If you don't know what those are, SHA-1 is essentially, I think the NSA technically made it a long time ago, and it's an algorithm. So we'll represent that with like a box here. So SHA-1 is an algorithm that you pass things into. So let's say you pass password in, and we'll just use password as an example. How a computer or a device would store that information is it would pass in each letter one at a time into the algorithm, and it would spit out a hash. What a hash is, well, generally speaking, a hash means that it's jumbled up the letters, right? Last week, or not last week, but the week before, we did that. We did like a pseudo cryptographic thing on Twitch, and we created our own. SHA-1 is well known. Okay, companies actually use this. Software is built in with SHA-1 in most cases, but it's not really used anymore because it's very insecure, which you'll find out today why it's very insecure. So if it takes password, right, it might generate something like A0XDNN, just a bunch of random crap, right? So let's say that's our function, and it's generated in 160 bits. So this is actually widely very good for an algorithm, because if I add a 1 to the end of this, you would probably think that it would add, maybe it would change this G, right? Well, that's not how hashing works, actually. It would change the entire hash completely. So that's interesting, because it makes you think, okay, you can't reverse engineer this then. So that's good when you're trying to protect a password, right? You don't want to be able to reverse engineer it. And quite frankly, the way that SHA-1 or any really hashing algorithm is built, there's no viable way to take this and reverse engineer it through SHA-1 somehow and get password 1. There's just no way. So for a long, long time, people were like, okay, it's safe. It's a good way to protect your password. However, the problem with SHA-1 is it's not salted. Now, if you don't know what salted means, that's okay. Salted essentially means that you can think of it like you're sprinkling salt over the middle of this, like this section right here. Just as an example, this isn't really what salting is, but it jumbles that up every time. So what I mean by that is if you put in password again, if I can spell it. So if you put password in again and put it through the SHA-1 algorithm, you will get the same hash as you did before. We call that unsalted. So that's a big problem, because I might as well, or I could at least write a program to say password equals that hash right there, right? So I could say that, hey, if you see this hash, then it might as well just be password. It equals password. And you're probably thinking to yourself, well, you'd have to know, in order to do that, you'd have to know the user's password, right? So, like, why would you, if you already know the password and you're matching it to a hash, then why are you even trying to hack a password? You already have it. Because you can do it two ways, really. Well, you can do it more ways than two, but I'm going to explain two. One is a brute force way. So how you would do this is maybe you would take a list of common passwords, right? And you would hash all of those passwords. Let's say 1 million of them. Okay. So you hash 1 million common passwords, and now you have a library or a list of common password hashes. Then you write a program that checks out a hash that, say, you take from a computer, because this is how they're stored. When you see a password stored in a system, you see a hash. So you take that hash and you copy it, you paste it in your little program, and it starts comparing that hash to 1 million common password hashes. And if it finds a match, it cracks the password. So that's the brute force way of doing it. You can also, let's say I write a rule, right? Because a lot of people will change their password, or they'll do capital P, right? Maybe an O, like a numerical O, for the thinking they're clever, right? So that's, password 123, like that. Maybe I think that is definitely more secure, right? Because it is a different hash, and you've essentially like increased the amount that you'd have to try by a factor of 3 minimum by doing this, so that it is more secure. However, it's very easy to write a rule, right? Maybe I write a rule that says capitalize random letters in the program and substitute O's for zeros sometimes, and add numerical values to the end of my passwords, such as 123, 321, 567, things like that, right? And it wouldn't take long for a computer, not my computer, but a good computer, to add those rules in, right? You can't use sequential numbers, 1, 2, 3. Has to be random, because they know about this trick. So if you're smart, if you're a good web developer, you might build in some of these rules that hackers know about in advance to protect from this exact thing, right? Because it would be harder for me to write a rule that says put in 782, like 3 random numbers, versus a sequential series like this. Of course, humans are stupid, and password 123 would be very easy to remember. I could tell you that's your password and you'd probably never forget it. So that's a benefit to us because we're lazy. And it would be harder for me to tell you your password is something like this, right? If I told you that today, you'd forget it by tomorrow, likely. So anyway, that's what we're doing. We're going to build a nice little GUI program that lets you import a hash that you can find, SHA-1 hash or MD5, and compare it to a list of common passwords and see if we can crack it. So let's get cracking. We have a lot of things to import, but the first thing I want to show you is let's actually hash some passwords so we have something to work with. Okay, and hashing is built in to Python with hashlib. I think it's built in. I don't think you have to pip install it. So I'm going to do import hashlib. And then we'll create a variable called password that we can pass in input. So it lets you, we'll just make it a terminal program for this sense. So if you do input and then we'll say password or something. Maybe like password to hash. And then we can use that variable later. So we'll just print SHA-1 hash, because we'll do two. We'll create a SHA-1 hash and an MD5 hash so we can use them later in our program. So we'll create a variable called setPass. We'll make that equal to bytes, and then we'll pass in the password, which will be the string input of the password. And then we have to say UTF-8, which is essentially the format of the password at that time. So we will say hash object is equal to, and then we can say hashlib dot, and then we can call our hash. So you can do MD5. In this case, I'll do SHA-1. I think if you just start typing it, you'll see, yeah, MD5 comes up, SHA-1 comes up. I'm using VS Code for this. And you can do 224 or 256, SHA-384, but we'll do those later. And then set pass. We're passing in the byte version of it so we can digest it. And we'll say guess password is equal to hash object dot, and then we have to digest it. So we do that by doing hex digest, open and close parentheses, and now we can print it. And we'll print empty string here. Let's see what that looks like. So I'm gonna run it, password to hash, password, and there you go, SHA-1 hash, there it is. And you can't see that because it's over my face. There you go. So there's our SHA-1 hash, okay? So let's print an MD5 one, and it's literally going to be, I'm just going to copy this whole thing and change this to MD5 hash, and just change, all I have to do is change this hash lib to MD5. That's it. The rest of the variables will overwrite each other, so it doesn't matter. Yeah, good. And then just for space, we'll add a few empty prints. This is just for aesthetics. You don't have to do this if you don't want, but it just shoves everything down so I can see it better, like that. So you have SHA-1 hash and MD5 hash right there. Cool. So now we can play around with our program. Let's go to an empty thing here. If you haven't already, I would download Tkinter, or import it rather. Pip install or pip3 install Kinter. Sorry, I know I call it Tkinter. You also need URLlib and OS and SSL. Actually, technically, you don't need SSL. I do for some reason. When I was building this, I had to scour the internet for, like, I'll call it an SSL ignore, because it was throwing a SSL error and I couldn't get rid of it. So I found it and it works. So if you don't get the error, you don't have to do the SSL part. That's fine. So I'm going to import Tkinter as TK because it's nice and short. And then I'm also going to import everything from Tkinter. From Tkinter, import everything. And then import URLlib dot requests, or request rather. Our hash lib, we need that. And finally, we need OS and SSL. Again, I said this last part, this OS and SSL, you may not need, but you'll know because if you run it without, I'm going to paste a line of code in, and if you don't and it runs, then you're good. If you run it and it says you have an SSL error, you might want to paste that in, which is fine. We'll go over that in a minute. So we're going to start with our GUI part of it. So we'll say root is equal to tk.tk. So I can call small tk for it. And then we'll make a title. You don't have to do the title, but I like it. I'm going to call it password cracker 9000. And then we'll have root.main loop, which will be, if you're not too familiar with Tkinter, basically a GUI is just a continuous loop. So what I like to do is create sort of the base, like the very base, and then I give this a ton of space right here. And then in my head, everything I write between root and main loop is contained within the GUI. Anything outside of it doesn't have to be inside the GUI. So I write it above it. That's just how I do it. I think that's probably a good idea to do that. So I'm gonna paste in this SSL thing. I will leave a link in the video if you're watching this on YouTube to all of the code, so you can just paste this over. I'm not gonna go over what this does because I actually have no idea. I wrote a little note here that says it solves an SSL error I was getting. Basically, I just Googled like the error I was getting in the terminal, and then someone said, yeah, if you write this, it essentially skips the certificate, or it validates it somehow, it verifies it. I don't know. But you could also bypass this because we're not, if you want to import the list of 10,000 common passwords into your program, you don't even need SSL or URLlib at all. You can just pull it from that save file. But in this case, I'm going to be using a GitHub link. So I'm going to actually just put these here, and then I'll write the rest here. So below this, I'm going to create some variables that we'll be using quite often. Some of them are colors, some of them are dimensions. So I'm going to say height is equal to 500. You can pass these variables in place, but I like to keep them as variables at the top so I can work with them later. So I like it at 500 and 500. These dimensions are totally up to you. I just found that that's a pretty decent size for that. Always run your code before you get too far in to see if you've screwed anything up. I misspelled title. Okay, there you go. Since it was so small, 500 by 500, somewhere like that. But the reason it was so small is because we haven't assigned the height and width to anything yet. We'll get there. And then I'm going to do gray and dark gray. I like dark mode on pretty much everything. So you'll see why I'm using this. You can do whatever colors you want, but I pass in strings of hex. I think that's what you call it, hex colors. Yeah, sure. But you can just type in white. I think you can just type in gray. I like it dark, so I pick my own custom colors. But at any rate, we'll use those. And then we are going to create a variable called common pass, which is going to be basically a online library of the 10,000 most common passwords. So this is what it looks like. It's just separated by enters, new lines, and it's just common passwords. This is scoured off the internet. Some provocative words in there. But at any rate, this is what we're going to use to compare. So like I said, you can copy this in. You could, I mean, it's very, very large, so I'd prefer to keep it online. Or you can leave it on this URL, but I'm just going to copy this URL. It's somebody's GitHub. Daniel Meisler. Security list, master passwords, common credentials, 10 million passwords list top 10,000.txt. Like I said, you can copy in that URL from my GitHub if you want, or you can write it out if you really feel you need to. So we're going to take the string of URL lib dot request, and then we're going to say URL open, pass in our URL as a text, like that. And then at the end here, we got to do a couple things to it. We have to read it. So after the parentheses, we'll say dot read, open and close. And then we have to say UTF-8 again. Remember, like before. Just like that. So you have close parentheses, dot read, comma, UTF-8. That will take in all of that stuff. Let's build out the rest of our GUI before we get too far. So we're going to build a bunch of stuff into it here. So we're going to create a canvas. Or say it's equal to tk.canvas with uppercase C. And we're going to pass in the root. And then we can give it the dimensions. So we can say height is equal to height, which is currently set to 500. Width is equal to width, which is currently set to 500. And then we can say the background is equal to gray, which is set to our nice dark gray here. And then we'll pack that in. So we'll say canvas.pack, and then open and close parentheses. Pack is a way to just sort of regurgitate it on the screen. We use pack quite a lot in this program, but I'll use place in other places as well, just to make it more aesthetically pleasing. Okay, and now let's make a frame. So a canvas will be, it's going to take that box that we've created and make it just all gray, and it will format it into 500 by 500. The frame is going to be like a piece of paper on top of the canvas that we can write stuff onto. That's just how I'm building it. You can put stuff right into the canvas if you want, the root rather. But I'm going to be pinning everything to the frame myself. So that's just how I like to build it. So tk.frame, and then we'll pass in the root, and then we'll say bg, which is background. We'll say dark gray, and then we'll pack that in. Frame dot pack. Actually, we're going to place this one. And we're going to say relx is equal to 0.1. Rely is equal to 0.1. Say rel width. I don't remember why I did this. I think pack will work just fine. But I'm just writing out the code that I wrote out last night for this. So I know it works. So I'm going to just place it. But I think pack will work just fine, honestly. So let's see what this looks like. There you go. See, I kind of purposely matched it to the color scheme of VS Code. That's what I was talking about. So this is the... It's actually funny because this darker gray around the edge is gray, and the lighter gray in the middle is dark gray. But I got lazy and didn't want to rewrite my code, so... Oh well. Just gonna have to know that those are reversed. so that bothers you, then just rewrite it backwards to what I'm doing. Whenever I say dark gray, just put in gray, vice versa. But there we go. We have our nice little GUI, so we can start adding stuff to this inner frame here. And I like to pack it in the center. You can do it to the left or the right if you want, but pretty much everything's going to be centered for me. So we're going to add a couple things here. Technically, you can pad things to give it space. In this program, I chose to add empty labels. So I'm going to say label 4 is equal to tk.label. Pass in the frame, not the root anymore because we're attaching things to the frame. bg equals gray. And then we'll just pack it in. Label 4.pack. And we can say side equals top. That has to be a string. Just like that. And I'll just put a note here. This is my spacer, so I can copy this and paste it in later if I need spacers. Just add that like that so I can see it. Okay, so you can do this a bunch of different ways, but how I chose to do it was I wanted you to be able to choose the hash of your choice from a drop-down menu. Paste in your hash, hit enter or run or crack password, whatever you want the button to say, and then it will spit out the answer at the bottom. So to do that, we have to create a drop-down menu. Let's do the title first. So let's create a label, we'll say below frame here. So we'll say label is equal to tk.label. Frame. Background, dark gray. And then we'll say text is equal to import a hashed password. Just like that. I like to add the little lines to sort of center it out. And then we can pack that in. We can say side top. I do the side top quite a lot. Make sure everything is spelled properly here. There we go. So right at the top, we have import hash password. We're going to make the foreground of that white. So to do that, fg equals white. So the text is white. There we go. Import a hash password. Looking good. And if you can see very closely, we have a spacer in there that we put in. It is the wrong color though, so let me change that. Okay. So now we have text, spacer, and then we want our drop-down menu. So to do a drop-down menu, we're gonna call option a variable as a list, and then we'll pass in some strings. We'll say SHA-1 is an option, and then we'll say MD5 is an option. Okay, I'm gonna put a little note here that says drop down menu for my own sanity. We're gonna say clicked. So we have to bind them. So I when I first wrote this, I did a well, we'll talk about that in a minute because we're not quite there yet. So clicked, just follow along with this. String var, open and close parentheses, and we can say clicked dot set. We can pass in option 0. So this is set is what it defaults to. So option index position 0 is just SHA-1. If you have a longer list, if you wanted to make this with like 50 different hashes, if there are even 50, I'm sure there are, then you could default to 1 in that list, or you could default to 0, which is pointing to SHA-1. Then we'll say drop equals option menu, which is essentially the drop-down menu, and then we can pin it to the frame, and we can pass in clicked and option like that. This is just how Kinter does drop-down menus, a little obsolete, and then we'll pack that in. Side top, call that a day. So let's see what that looks like. We may have to change the font, or not the font. Oh, actually that looks pretty good. So we have text, spacer, drop-down menu. So now we can choose between SHA-1 and MD5. And like I said, you can add more. I just chose to do 2 on this one. Once the GUI is all built out, we'll start doing the actual password cracking. I just thought it'd be really cool to build like a little tool for it. Okay, so that is good. So now we have to add an entry. So below that, we're gonna add another spacer. Actually, you know what? Let's just move this spacer. We don't really need a spacer between those two, but we will need it for the entry. So I'm just gonna move that down below. Yeah, that's fine. That's fine. So there's no more spacer there. I put it right here. Doesn't matter. Like I said, these spacers are just kind of silly anyway, but let's make our entry. So we'll call it hash entry. We can say tk.entry. As you guessed, pass in the frame. Make it nice and colorful. Actually, we want white for the background. Hash entry dot bind. So this is where we can bind the key to. I thought it was kind of annoying to have just clicking the button. I wanted you to be able to click the button and hit enter. So you can do that with bind, and then you can pass in return, which is just the return key. And then you can add what it does, like what the... So when you add a button, you can add a command. This next part is calling a function. So I'm going to call this right now crack pass. Okay, because we're going to make up here, we're going to define crack pass. So I'll just make that right now so you know that's pointing to that. So when you hit return, I want it to run this function. That's all I'm saying. The function will be to run the to run just this part. So return crack pass, that's what I'm binding the entry to, and then I can pack it in. So we can say hash entry dot pack side top. Let's take a look at that. I'll just hit return. So now we have our entry, and when I hit enter, nothing happens. I get an error down here because I haven't told to do anything yet. Cool. I'm going to add a spacer. I just called it label 2. This is label 4, label 2. And then we're going to add, so we have spacer, and then we're going to add a button. The button, we'll say, is equal to tk.button. For those without enter keys, background gray. Or I'm sorry, we just want text. Text is equal to, so this is the button text, we'll say like crack password. button.bind. So here we go with the bind again. Typically you don't have to bind buttons. They just, when you click them, they do stuff. But when you bind the enter key to return, you can't. I found that I couldn't find a way without binding button 1, which is the left click, to point it to crack password. I suppose I could probably just do command, but this is more fun. So just like we did with the entry return bind, we're returning the left click bind. That's all. And I guess this gives us more flexibility down the road. If you wanted to add in like a right click feature, you could, but I have no need to right now. So we'll say pack, and then we'll side top. We're just stacking, we're stacking pancakes on the top, the widgets right at this point. So see what that looks like. Button 1 is name button is not defined. I spelled it wrong. There you go. So, I mean, you could add a spacer here if you want, but it doesn't really matter. So you can switch between SHA-1 and MD5, put it in, hit crack password, and then nothing happens down here, and as well as hit enter, and that's taking something right now. It's running crack pass, which is just returning, so it's throwing an error, but that's pretty much it. I have this empty label here. This actually should be dark gray. This is another spacer. I think I probably added this in for something, but you actually don't even need it at all. Feel free to skip that if you're coding along with me. Okay, let's get to the meat and potatoes of what's going on here. So there's quite a lot. What we're going to do in this function, we have to pass in the event, and the reason for that is for the binding. So when you run crack pass, it takes an event. And so when I'm running bind crack pass, this is the event. And that's the event right there for that. So you just have to add event in to make that happy. So we're going to say, we're going to create a new variable called hash function. And we're going to clicked.get, which gets the information from whatever you've selected in the drop-down menu. So click.get is essentially what option you've chosen, SHA-1 or MD5. And I'm writing this in so I can call it later and say, hey, if I've chosen SHA-1, run the SHA-1 decryptor, we'll call it. If it's the MD5 one, run the MD5 one. If it's something else, run that. So we'll write in those if statements in a minute. And then I'm going to create hash entries for SHA-1 and MD5. So we'll say SHA-1 hash is equal to hash entry dot get. So now we're getting the click, and we're getting like the function that we're running, and we're also getting the hash. So MD5 hash is equal to the same thing, hash entry dot get. It may not use it, so when we run SHA-1 and MD5, we'll have the same thing, but it depends on what you've clicked on what will run, if that makes sense. Probably a better way of doing that, but that's just how I chose to do it, and it works just fine. So I'm going to say if the hash function is equal to option index 0, which is SHA-1. So remember down here we labeled option, and this is a list, so we can call SHA-1. So I'm saying if that function is SHA-1, now I can say for guess in common pass, which is that huge library of common passwords, we're going to split it. We're going to split it by new line. So how to do that? You just put in that right there. So you can split, remember you can split by commas, you can split by spaces. We're splitting by new line. So we're saying for every new line, check it, essentially. So for each password, we're going to say guesses is equal to hashlib dot SHA-1. So what we're doing here is we're converting the guesses into SHA-1 hashes so we can compare the hashes. UTF-8. And then we're going to digest it. Hex digest. This is no different than what we've done before. In this, remember, we're basically just doing this. Hash object digest. We're just doing it all in one large line here. So hashlib SHA-1, bytes, pass in the guess, UTF-8, digest it. That's it for that line. So now we have the hash as guesses, so we can say, we're going to create a label for this right here. Is equal to tk.label. We're going to pass this into the frame. So we're just getting ready to print out if there's a match or not in this line. Dark gray. And then we'll give it a text of the password is, and then we can append the string of guess because guess is currently an integer. And then we'll make it colorful. Foreground is equal to, I have this E5. I think it's just gray. You can put in white here or hash E5, E5, E5. That's just like an off-white. I just liked it better. So our label is ready if we get it right. So if we get it right, we'll say if guesses is equal to the SHA-1 hash, right? Then we'll pack in our label. So that's why I wrote the label right there. So we can just say, hey, pack it in. Can't spell, but, and then we'll say side is equal to bottom. That'll just put our guess at the bottom. And then we can return. But if we don't get it right, we're not going to do anything. So essentially it's saying, this is for loop. If the guess is in common password and it equals to the SHA-1 hash, then pack it in. If not, then we'll write an else statement at the bottom saying, hey, we couldn't find it, sorry. So let's go all the way back down to our if statement here. And we're literally going to write the same thing. So I'm going to copy this. And I'm just going to change this to MD5. Because, and also option 1. Because we're doing the same thing. We're digesting it the same way. We're just taking hashlib MD5 instead. And we can even leave the label the same. Because it's going to choose one or the other. It's not going to run both. So let me just double check and make sure that is correct. Yeah, we have to change if the guess is equal to the MD5 hash. So we'll just change that there. Think that looks good. Then pack it in and return. Yep. Okay, so that's done. Let's write an else. And then we're going to call this label, I don't know, 2, 4. What number haven't we used yet? 6 is equal to tk.label. Hey, Mr. Spar, welcome. We'll pass in our frame. don't know why I always type framer. We'll make this nice and colorful, dark gray. Our text will be, yo, homie, we did not find that. So we'll say that password is not in the database. And we'll make that foreground the same gray. Right there. And we'll pack that in. Label 6 dot pack. And we'll show that at the bottom. Side, bottom. Just like that. Good. Cool. Give me a password to check. Something that you think would be relatively easy to crack. Something that you think might be in the top 10,000 most common passwords. Perhaps. We'll see if we can crack it. 0, 0. QWERTY. Okay, let's try QWERTY. So there's QWERTY hash. Boom. Instantly. Instantly cracked it. Okay. What else we got? 0, 0, 0, 0. That's 100% in there. Boom. The password is 0, 0, 0, 0. Wow, that's quite the password. Let's try that. I don't know if that'll be in there. What is that? Azure TYUIOP. If that's in there, I'll be shocked. Oh, it's in there. Wow. Oh, my keyboard's different. My keyboard has that all spread out. That is a lot of numbers. I don't think that'll be in there. We can try it. I doubt it, though. How many 7s is that? 2, 3, 4, 5, 6, 7, 8, 9. Oh, I see. All right, let's try it. Nope, that's not in there. Let's do this one, C2H5OH. I feel like that's not, it can't be common. There's no way that's in there. There's your SHA-1 hash. Oh my god, it's in there. Can you see that? C2H5OH is in there? Dear God. What? What? Why would you ever use that? Does that mean something? Dragon Balls. Look at this password. GHJ CN BNENRF. That makes no sense to me. Let's do an MD5 hash. Come on, there's no way. That's just complete gibberish. It's instant. Yeah, it's not in there. All right, so that's it for today. Thank you so much for watching. If you like what you see, and you're watching this on YouTube, hit the like button. If you're watching this on Twitch, thanks for being here and asking questions and following along with me. I will be doing some streaming tomorrow, Sunday. So if you're around for that, I'll do that tomorrow morning, most likely. I'm going to the beach tomorrow, so not going to be doing it all day, but really appreciate you guys' input and helping me spell label correctly. But I'll see you guys next time. If you have any ideas and you're on Twitch and you're watching this, check below. If you scroll down, you'll see a suggestion box. No one's put anything in there yet, so if you have an idea for me that you want me to code or you think I could do something better, go ahead and put it in that suggestion box, and I'll take a look at it and see what we do from there. But yeah, thanks for stopping by, guys. I love you all, and I'll see you later. Bye.